16a. What is equipotential surface? Answer. Potential is same at all points on the surface. B. Write two properties of equipotential surfaces. Answer. 1. No work has to be done to move a charge on an equipotential surface. 2. Two equipotential surfaces never intersect each other. 17a. What is the working principle of a moving coil galvanometer? Answer. A current carrying coil placed in a magnetic field experiences a torque which is proportional to the strength of current passing through it. B. How will you convert a galvanometer into an ammeter? Answer. By connecting a low resistance called shunt is parallel to the galvanometer. C. An ammeter is always connected in series with a circuit. Why? Answer. An ammeter is a low resistance instrument. So, it does not change the resistance in the circuit and hence gives the true current in the circuit. 18. Using Huygens concept of wavefront, derive Snell's law of refraction. Answer. In triangle APC, sin I is equal to BC by AC equal V1 torque by AC. AC sin I is equal to V1 torque. In triangle ACE, sin R is equal to AE by AC equal V2 torque by AC. AC sin R is equal to V2 torque. From 1 and 2, sin I divided by sin R equal V1 torque by V2 torque equal V1 by V2 equal constant. This is Snell's law. 19a. Which one of the following is correct graph showing the variation between the maximum kinetic energy of the emitted photoelectrons and the frequency of incident radiation for a given photosensitive surface? Answer. 3. B. A photosensitive surface has a work function of 2.00 eV. Find the maximum kinetic energy of electrons ejected from this surface by radiation of wavelength 300 nm. Final answer is equal to 3.43 into 10 raised to minus 19 joule. 20. A. State Gauss's law in magnetism. Answer. The net magnetic flux through any closed surface is 0. B. A short bar magnet placed with its axis at 30 degree with a uniform external magnetic field of 0.3 T experiences a torque of magnitude equal to 5 into 10 raised to minus 2 joule. What is the magnitude of the magnetic moment of the magnet? Answer. Torque is equal to mb sin theta. M is equal to torque by b sin theta equal 5 into 10 raised to minus 2 divided by 0.3 into sin 30 equal 0.33 am square. 21. With the help of a circuit diagram, explain the working of a half-wave rectifier. Draw the input and output waveforms. Answer. During the positive half of input signal, A is at high potential with respect to B. Then the PN junction diode is forward biased and current flows through it. Thus an output voltage is obtained across RL. During the negative half of input signal, A is at low potential with respect to B. Then the PN junction diode is reverse biased and no current flows through it. Hence, no potential difference obtained across RL. The same phenomenon is repeated in the next cycle. 22a. Obtain an expression for the equivalent capacitance when two capacitors C1 and C2 are connected in parallel. Answer. Q is equal to Q1 plus Q2 is equal to C1V plus C2V. 1. If C be the effective capacitance of the parallel combination, then Q is equal to CV. 2. Comparing equation 1 and 2, C is equal to C1 plus C2. B. Given graph shows variation of charge Q with potential difference V for two capacitors C1 and C2. Both the capacitors have same plate separation but plate area of C2 is greater than that of C1. Which line corresponds to C1 and why? Answer. 23a. Kirchhoff's voltage law is in accordance with the conservation of. Answer. 2. Energy. B. With the help of diagram, arrive at the Wheatstone's principle. Answer. 24a. What is the working principle of an AC generator? Answer. Electromagnetic induction. B. With the help of a diagram, explain theory and working of an AC generator. Answer. 25A. Draw a ray diagram of simple microscope showing image formation at least distance of distinct vision. Answer. B. The magnification of a compound microscope is 20. The focal length of the eyepiece is 5 cm and the image is formed at the near point. Find the magnification of objective lens. Answer. M is equal to 1 plus D by Fe equal 1 plus 25 by 5 equals 6. The final answer is 20 by 6 equal 3.33. 26A. A spherical shell of radius r is uniformly charged with charge plus q. Using Gauss's law, find the electric field intensity at the point 1. Outside the spherical shell, 2. On the surface of the spherical shell. Answer A. Answer 2. B. A point charge causes an electric flux minus 2 into 10 raised to 14 n m square by c to pass through a spherical Gaussian surface. 1. Calculate the value of the point charge. Answer. 2. If the radius of the Gaussian surface is doubled, how much flux would pass through the surface? Answer. Same or minus 2 into 10 raised to 14 n m square by c. 27A. What is Lorentz force? Answer. When a charged particle moves in a region where both electric field and magnetic field exist, then it experiences a net force called Lorentz force. B. The figure shows the path of motion of a charged particle in a uniform magnetic field. 1. What will be the direction of magnetic field with respect to the velocity of the charged particle? Answer. Magnetic field is perpendicular to the direction of velocity or magnetic field is into the plane. 2. Show that the frequency of revolution of charged particle is independent of the radius of the path. Answer. Frequency is the independent of the radius of the path. 3. Is there any change in kinetic energy of the charged particle? Explain. No. F is equal to Q V into B. Magnetic force acts perpendicular to the velocity of the particle. This means that the magnetic force does not do any work on the particle. Therefore, the speed of the particle and hence its kinetic energy does not change. 28A. With the help of phasor diagram, find the impedance of a series LCR circuit. Answer. Impedance Z is equal to root of r square plus xc minus xl the whole square. B. A series LCR circuit is connected to an AC source of variable frequency as shown in the figure below. At what frequency the impedance of this circuit will be minimum? Answer. 29A. Draw the path of a light ray through a prism which suffers minimum deviation. Mark the angle of deviation, angle of incidence and angle of emergence in the figure. Answer. B. Using the above diagram, show that the sum of the angle of deviation and the angle of prism is equal to the sum of the angle of incidence and angle of emergence. Answer. In the quadrilateral AQNR, angle AQN is equal to angle ARN equal 90 degree. Therefore, angle A plus angle N is equal to 180 degree. 1. In triangle QNR, angle N plus R1 plus R2 equal 180 degree. Comparing 1 and 2, we get A is equal to R1 plus R2, 3. From triangle MQR, D is equal to angle MQR plus angle MRQ. Final answer, D plus A is equal to I plus C. C. What do you mean by angle of minimum deviation? Answer.